So now I would like to welcome you all once again to the session Raw Material and Mixing, Challenges and Future Trends. Firstly, some general remarks from my side. If you have any questions for the speaker, ask them under the Questions tab, and I will address the questions right after the presentation directly to the presenter. So furthermore, if possible, you can download approved presentation under the Documents tab. So, and now I would like to start with our first presentation of the session, which will be held by Dr. Stefan Gerl from Maschinenfabrik Gustav EIRICH GmbH und Co. KG. And the title of his presentation is Continuous Coater Supply with Quality Assured Coating Slurries Produced with EIRICH Conti Feeder Process. So, Herr Gerl, the stage is yours.
Thank you, Mrs. Gottschalk, for your kind introduction. Ladies and gentlemen, I would like to start to give a short overview about the EIRICH activities in the field of lithium-ion battery manufacturing. We are not only in the area of preparation of coating slurry. EIRICH supplied machines already in the preparation of the raw materials like cathode material preparation, where precursors are mixed with the lithium source, or the next step then the so-called functionalization of the cathode material to improve the cathode material properties in the final electrode. The same EIRICH supplied machines in the synthetic graphite preparation, where pitch and coke are mixed homogeneously and needed to prepare then with a graphitization process the anode material. And let's say more new developments like the silicon carbon composites, where also some functionalization has to be done. All these raw materials ending up in the electrodes. There we have the mixing of coating slurry. We have also supplied machines for the preparation of extrudable masses with significantly higher solid contents. And last but not least, also machines which are used for the dry dispersion, for dry electrode processing, where no liquids at all are used and binders are fibrillated. The EIRICH scope of supply is not only the machine, the mixer, it is also the raw material handling, all the weighing and dosing system, of course, then the mixer and all necessary peripheral equipment. And last but not least, the control system, which is the brain for the complete arrangement of equipment. Today, we just want to concentrate on the mixing of coating slurry, and we will not touch the other parts anymore. How does an EIRICH mixer work? EIRICH invented the planetary mixer in 1907, and in 1924 we then designed and developed the EIRICH mixer with a rotating mixing chamber, which is doing the transportation of the raw materials within the mixing chamber, and this is a big difference than to the planetary mixer with its static chamber. By this, the material moves to the eccentrically mounted rotor tool, which now allows us to design the shape of the tool independently from transportation. So it can be designed just to focus on the mixing task. We can also vary it then in a speed in a very wide range, from very slowly and gentle and soft with less than 1 meter per second, or even very aggressively with up to 50 meters per second, like it can be used for the dry electrode preparation. Of course, we can rotate the mixing tool counterclockwise or clockwise with the mixing chamber, and together with the shape of the tool, we can introduce different shear forces. The diameter of the tool is always 50% of the diameter of the chamber, and this by this we are acting on a big volume at the same time. And the system also allows to control torque so that we can produce excellent dry mixes within the machine. We can do also excellent kneading, controlling the torque level, but also we can do the slurry making. To prepare the slurry, the machine is put into horizontal because some of the machines development out of the 70s were inclined, but the liquid will not flow up the hill. An additional feature is the wall and bottom scraper, which is designed as a scraping element in the lithium-ion battery industry, with plastic knives really taking away all adhesions on the wall and bringing it back into the slurry to make sure that all the solids are really well dispersed inside of the machine. the lithium-ion battery industry forced us to introduce a double-jacket cooling system. It was not necessary for almost 100 of years. And so today we're offering machines with a double-jacket cooling system, which will rotate together with a mixing chamber. It is directly connected, and the liquids which has to be introduced into a rotating system are charged with a special transfer system. We can put the complete interior mixing chamber with the same design, same tools into a pressure vessel, which allows then us to operate the machine in under pressure and vacuum for a superseded degassing of the coating slurry. We have developed special discharge gates and extraction systems for the lithium-ion battery industry, which allows us to discharge the material in a very controlled manner and very efficiently. For high-scale, high-capacity production plants which run 24/7, we have also installed a high-pressure cleaning system which allow wash in place and clean in place. This is usually not available for the very small lab machines, but for the reasonable sized production machines, we can offer this. How does the process works inside of the EIRICH mixer? We follow a certain philosophy that we say our mixer is capable to run through any consistency. So we promote to add all dry raw materials. This includes the active material, of course, a conductive carbon, as well as a binder. We started with a first intensive dry mixing process, which usually takes 1 to maximum 2 minutes. Firstly, to separate the binder particles from each other, to put in the active material and the conductive carbon in between, and to disperse the conductive carbon already. Then we're adding very quickly a certain portion of liquid, which is usually 40–50% of the total. We are wetting the surface very efficiently inside of the machine of the particles, and then the binder starts to solve, and it will form a plastic body which can be sheared and kneaded over a period of roughly 5 to 10 minutes by experience. Of course, this can be prolonged and you can change the speeds and so the shear action. After this very important phase, we have to add the missing liquid. We call it a dilution phase. This can be made relatively quickly, within 2 to 5 minutes. And for water-based anode systems, we add then in the final end the liquid binder like SBR, which is done at very low speeds, not to stress the sensitive binder too much. The shear rate, the speed, the time can be individually adapted in every phase, and even phases can be split into sub-phases to allow an excellent, let's say, shear stress, to allow excellent dispersion of the partners of the raw materials. The total preparation time takes between 15 and 20 minutes. And we then have the ability with our system to make an inline viscosity measurement before we discharge the system, before we discharge the slurry into the following transfer system. This is a special procedure, a measuring procedure, which allows us to change the rotor speed in different steps, and we can ramp it up and ramp it down like a rheometer. And by this, we measure the motor power absorption, the torque, and can calculate the viscosity. Of course, this viscosity measurement must not be at the final end. It could be also part of the dilution phase in between at higher concentrations, and would by this allow us to control and to adapt the amount of liquid added in the final phase to control slurry quality. If you want to degas, we have two options. If we have a normal mix solver atmospheric operation, we have to do the degassing after transfer to the storage tanks, applying vacuum, and then we are stirring it and taking off the gas bubbles. With a vacuum mixer, an EVAC mixer, we can apply vacuum already in the final end of the liquid addition phase to prevent dust to be sucked out, and then the complete preparation will be made under vacuum, so there are no gas bubbles introduced into the mix already, and we have a perfectly degassed product already at the final end. If you compare different mixing systems, and I have made this here with a special chart where I put the retention time over the throughput rate in the log-log graph. We have on the one hand the PD mixer, the classical PD mixer, with preparation times of 6 to even 12 hours and more. And we see that we have with a 1,500 liter PD mixer, or even with a 2,000 liter PD mixer, we have a throughput rate which is in the range of about 100, maybe 200 liter, and will go down, of course, if you increase the time. On the other hand, we have the continuous extrusion systems with different screw sizes, screw diameters, which is also running in the range of retention time of roughly 1 to 10 minutes in the factor of 10. And both systems have the problem that if you increase the retention time, you decrease the capacity. And this is not so different with an extruder. So you are not independent in retention time and throughput rate. So this changes your product if you want to go for a higher capacity or for lower capacity. In contrast to this, the EIRICH Mix Solver offers a very good opportunity to adapt your product in a wide field of parameters, because we can change the filling rate. We can go to up to 2 batches per hour. We can change the retention time by this, and then you have a field where you easily can adapt your parameters and to optimize your product. We have different sizes of machines, and if we look for the actually planned gigafactories, which are in the range of 4, 8, or 16 up to 32 gigawatt hour, we see that with our machine named R16, 900 liter capacity, we can match with one machine the 8 gigawatt hour capacity. With an R12, which is a very common machine at the moment, we can go to 4 gigawatt hour with one machine. And so we are well, let's say, prepared to go for the high capacities. Why? You see, with the PD mixers, you have to adapt or to use a huge number of machines in parallel to allow the production rate of a gigafactory. If we compare the energy consumption, it's quite interesting to see. If you have a 1,500 liter PD mixer, which is a filling of about 1,200 liter, they have installed power on in total 290 kilowatt, 160 kilowatt for the solver tool, and 132 kilowatt for the planetary tool. Retention times of 6 to 11 hours. And if we calculate an average energy consumption of 93 kilowatt over the time, then we end up with 1,001 megawatt hour for one batch of 2,300 kilo, for example, if we have a cathode material. And by this, we can calculate, even in a very positive way, with 6 hours energy consumption of 465 watt hour per liter. The extrusion systems with its very short retention times, they promote that they can run with about 25 watt hour per liter. But if you really compare the installed energy, the motor power and the throughput rate, this value should be significantly higher. On the other hand, by experience in production plants, we know that with a 400 liter R12 mixer and the 230 liter NCM cathode material, we have an installed power of only 60 kilowatt. We have a mixing time of about 20 minutes for the cathode material. We need 3.8 kilowatt hour per 450 kilogram, and by this we are ending up with a value of only 16 watt hour per liter. And if we compare this value with a traditional value from the planetary Desper mixer, we see that we can cut down the energy consumption by 96%. The continuous mixing plants are offered in the market, and of course is always a question how the continuous they are really. We have the extruder, and also the extrusion system consists of batch and conti equipment. Of course, the extruder itself is a continuous operated machine and will be fed continuously from the dosing systems, but the dosing systems itself will be fed in a batch manner from the storage area. We have to prepare a binder solution, which is usually also made in a batch way. And Then the final slurry is transferred into degassing tanks and storage tanks because the degassing cannot take place completely inside of the extruder. And these tanks are batch again. From here, we are then pumping the slurry portion-wise or continuously to the coater, which at the end really operates continuously. This was the reason why we said, okay, the EIRICH mixer is capable to run very short time. We can refill a tank, and by this we can also supply the coating slurry in a exactly similar or same way like the extrusion system. And by this we can combine the strengths of a batch-wise system that we individually can weigh out our material, we can adapt the parameters, we can optimize the slurry preparation, and then we transfer it into a storage tank, and from here we are buffer tanks then to the coater, and the continuous supply is then from the last tank to the coater. If you compare how this looks like with a pure batch process, it is almost identical. In the pure batch process, we are mixing, we are weighing out, we are mixing, then we are transferring it into a storage tank, we are doing the degassing inside of the mixer and the storage tank, and then the tank is moved to the coating line next door, connected, and then the discharging of this slurry tank to the coater takes place. With a conti feeder process, we can do it exactly the same. For low capacities, we only need one tank because we can then refill or fill the tank. We can discharge from the tank with a perfectly degassed slurry to the coating line. In the meantime, when this tank is discharging, we can make the next batch, we can degas a batch, we can cool it down inside of the machine, and then we discharge this machine into the transfer tank, and then it starts again to fill the coating line. Of course, this will not work for high capacity plants. This is the reason why we put in some more buffer tanks so that we discharge a batch, we can qualify the batch, we can take samples, analyze it in a lab, or we can analyze it inline with sensors, then transfer the qualified batch into a buffer tank. From the buffer tank, then we transfer it to another buffer tank, which is usually just a stirred tank without double checked cooling, without vacuum, to provide enough slurry then in a continuous way to the coating line. Of course, all this will only work if we have a control system which takes care on all the signals. So we have the material stream, we have a lot of signals. For example, we can monitor the raw material coming in by barcode reader or QR code readers, so that we know at any time what material will be ending up in a certain batch. Then we are weighing out, we can monitor exactly the amount of material which is weighed into a batch. It's the same for the liquids. Then during the processing time, we can monitor energy consumption, motor power, product temperature, process times, of course, pressure and viscosity inside of the mixer. The same then within the tank system. All these data will be collected via the PLC system on a computer system. Here, EIRICH offers then with a ProView web-based data visualization tool a strong, very strong tool to monitor the quality and what happens inside of the equipment. So we can compare batches, we can, let's say, pick out data streams, we can make YX diagrams out of the data. It's an extremely strong tool, and of course, all data are stored in a database. And this is then the basis for data mining or artificial intelligence examinations and analysis of the production process. EIRICH offers with a QualiMaster system in the LIP version.
Come to an end slowly so that we have time for the questions then.
Yeah, we have 3 different versions, the Eco, the Profi, and the Profi Plus, which mainly, let's say, are different because of the installed sensors. The Profi version additionally offers the viscosity and density sensors, and the Profi Plus version, the particle size distribution and concentration sensors. We have already sold several plants for gigafactories. The small concept is for, let's say, capacities 0.5 to 3 gigawatt hour. This one R12 mixer. We actually ship a machine or a plant system with 2 mixers in parallel using 1 peripheral equipment for dosing for a capacity of 5 to 6 gigawatt hour, which will go into operation in autumn this year. And we are planning big gigafactories with one line capacity of 13 to 16 gigawatt hour with 3 to 4 machines in parallel. This is a short view in such a gigafactory with an EIRICH mixer as a central element, then transfer tanks and also the dosing units for the raw materials. Of course, we have lab equipment which is necessary to make the examination work first, with an EL10 or EL5 lab machine with double jacket cooling system, a 75-liter machine, RO8 back, and we have, of course, peripheral equipment like liquid dosing systems to allow an automated work even with the lab machines. And if we don't have a vacuum machine, we have additional vacuum covers with agitators to allow degassing within the same tank without decanting it into transfer systems. Thank you very much for listening. Be ready to change, and hopefully we can, let's say, meet you at our booth, where you will also be able to, let's say, receive the foils and slides of my presentation. Thank you very much for listening, and now I'm open for questions.
Okay, thank you very much, Herr Gerl, for the insights into the EIRICH feeder process. I will start directly with the first question, which comes from me, and this is what solid content is possible with the process you are going with?
Generally, because we are coming, let's say, we are starting from dry and go via the full plastic phase with a solid content which is well above 90%, and then we are diluting to the typical solid contents in anode 50%, 50, 60%, in cathode up to 76%. At the end, the limit is always the viscosity for the coater. So we could go, of course, even higher, but then the coater is usually not able to coat it anymore. So basically, there's no limits at all.
Okay, thank you very much. And the second question is, how is the EIRICH mixer cleaned in the Conti feeder concept?
As I mentioned, we have a high pressure cleaning system inside, and we're using this system parallel to the operation. So we are not having, say, we have, of course, an own cleaning procedure, but we usually add the liquid we have to add anyway into our batch via this high pressure cleaning system, so that we wash away during the preparation process already some adhesions like powder sticking on the cover of the machine. And by this, we are not producing any waste. So the liquid which has to be added anyway will be used also for washing away any adhesions during the preparation process. And this allows us then 24/7 operation without interruption.
Okay, thank you. And now we are coming to our last question. Is the quality master concept a new development from EIRICH?
Yes and no. Quality master concept was developed in a very similar way already decades ago for the foundry industry, where we have also batch-wise preparation of foundry sand, which then are supplied continuously to the casting lines. And we just adapted this concept to the lithium-ion battery industry. Of course, there's different sensors inside for the slurry, but the general concept is well known and well introduced into 24/7 full-scale production plants in the industry.
Okay. So thank you very much again, Mr. Gerl, for the nice presentation. And now I would like to invite everyone to go to our session, to our next talk in our session, which is by Alberto Masi from Netsch Feinmaltätig GmbH. I hope I see you again there. Thank you very much.
Thank you very much for listening.